Okay, so 8-2 today. Objectives, we're going to graph quadratic functions using vertex form. Okay, so 8-2 quadratic functions in vertex form. So instead of having just y equals x squared, we're going to put some transformations on it. Okay, so the equation we're eventually going to end up looking at is y equals a times x minus h quantity squared plus k. And we're going to talk about each of these variables as we go. So the first variable we're going to start with is k. So how does the graph of g of x equals x squared minus 4 compared to the graph of f of x equals x squared? Well, let's graph it and see what happens. Okay, so here's Desmos. I have my parent function already graphed. So y equals x squared minus 4. Huh, well, look at that. Okay, here's my vertex. Here's my vertex. Okay, looks like it just got moved down 4. Okay. So k is our vertical translation. So the value of k translates the graph of the parent function vertically k units. Okay, our vertex is at 0, k. Okay, so k is part of your vertex. Okay, this value of k does not affect our axis of symmetry. Okay, so big thing to know. We should know this by now. We've done lots of transformations. Adding a constant at the end moves our graph either up or down, depending on if it's positive or negative. Okay, so let's look at a few examples. How does the graph of each function compare to the parent function? H of x equals x squared plus 3. Pause the video, try this one. That just moves up 3. Okay, j of x equals x squared minus 2. Pause the video and try that one. J just moves down 2. Okay, so let's move on to the next letter. Okay, remember it's y equals a times x minus h quantity squared plus k. This time we're going to focus on the h. Okay, so let's see what happens if I have x minus 3 quantity squared compared to our parent function. Okay, so y equals x minus 3 quantity squared. Again, look for where our vertices are. We go from 0, 0 to 3, 0. And I have a minus 3. So just like all of the other transformations we've talked about, when I'm with the x, this is my horizontal translation. Okay? So the value of h translates the graph of the parent function horizontally h units. The vertex of the graph g is at h, 0. Okay, so look, again, it's always the opposite of what we see. Okay, so the value of h translates also our axis of symmetry horizontally. Okay, so not only does h move our vertex, it also moves the axis of symmetry. Okay, so big thing to remember with h, it's always the opposite of what you see. Okay, so if it's x minus something, it's going to move to the right. If it's x plus a number, it's going to move to the left. Okay, and this also moves our axis of symmetry. Okay, so a few examples real quick. Pause the video and try each one. H of x equals x plus 1. Well, it's the opposite of what I see, so this goes left 1. Okay, x minus 5, opposite of what I see, it goes right 5. Right, so let's put them both together. What happens if I have both h and k? Okay, so first example, x minus 1 quantity squared minus 3. Okay, so if I go back to Desmos, x minus 1 minus 3. Well, started at a vertex of 0, 0. My new vertex is now 1, negative 3. So it looks like putting h and k together tells us our vertex. Okay, and I'm not going to go through these other two because it does the same thing. Okay, so big thing to know. The values of h and k determine the location of the vertex in the axis of symmetry. Okay, so the vertex, okay, so big thing to know, the vertex is at the point h, k. Big thing to remember, h is the opposite of what you see. Okay, and then the axis of symmetry, I abbreviate this A of S, is the equation x equals h. Okay, because we want that vertical line in there, and that's a buck sign. Okay, big thing to take away. The vertex is at the point HK, and our axis of symmetry is the equation x equals h. Okay, so let's throw some more letters in there. Okay, so if I have x minus 1 quantity squared minus 3, okay, the graph we just had, let's graph it with a 2 in front of it and see what happens there. Okay, so I'm going to turn off the parent function just for now. I'm going to take the same equation and put a 2 in front of it. Okay, so how did I get from the red to the blue? Well, notice the blue is quite a bit skinnier. Okay, so just like we talked about in 8-1, putting a into the equation makes my graph skinnier or wider. Okay, and the same thing happens with those. Okay, so the value of a does not change our vertex. Okay, the sign of a affects the direction of the parabola. Okay, so for example, if I make it negative instead of positive, notice it's still skinnier, but it also flips it upside down. Okay. So a affects the direction. The absolute value of a affects the width. Okay, so the function is this function that I put on this screen a couple times now is called the vertex form. Okay, because we can see what the vertex is. Again, remember our vertex is h comma k. Then the graph is a translation that translates h units horizontally and k units vertically. And I'm going to give you a handout that has each of these variables explained a little bit better in it. Okay, but big thing to know, h comma k is my vertex. Okay, so let's talk about how does the graph of f of x equals -3 times the quantity x minus 5 squared plus 7 compared to the graph of the parent function. Well, let's go one thing at a time. I like to start here. We go, since it's +7, it moved up 7. Okay, I like to look at h next. Okay, it's negative, so remember it's the opposite. This goes to the right 5. Okay, what does the 3 do? Well, it's skinnier by a factor of 3. And can't ignore that negative. We have a negative too. So the negative opens down. Okay, it flips it upside down. And that are the transformations here. Okay, so all of this helps us to graph using vertex form. Okay, so we're going to graph the equation -2 times the quantity x plus 1, quantity squared, plus 5. Okay, so the first thing we need to do is plot the vertex and the axis of symmetry. Okay, so I always like to start with my vertex. The vertex, again, remember, is HK. So H, again, is the opposite, so -1, K, 5. Okay, so let's go ahead and plot -1, 5. Well, -1, 1, 2, 3, 4, 5. Okay, using this, we also know our axis of symmetry. Axis of symmetry is x equals h. Well, our h value is just -1. Okay, so I always dot my axis of symmetry in there because I know I have to reflect it. Okay, so this is the axis of symmetry, just a vertical line. Okay, the second thing they say is to evaluate the function to find 2 other points. I usually don't do 2 points. I usually just, well, we can do one. Never mind. Okay, so we can pick any x values we want. I personally always try to start with 0 because 0 is very easy to plug in for x. So if I plug in 0, let's figure it out. Okay, so we're going to have -2 times 0 plus 1 squared plus 5. Well, order of operations, I start here. 0 plus 1 is 1. So I have -2 times 1 squared plus 5. 1 squared is just 1, so -2 times 1 plus 5. -2 times 1 is -2 plus 5 gives me the point 3. So the first point I have is 0, 3. So let's go ahead and graph 0, 3. Well, 0, 3, 1, 2, 3. Now the cool thing is I have this axis of symmetry. That means every point I plot gets reflected over an equal distance. Okay, so my red dot is exactly 1 space away from the axis of symmetry. So I just go to the axis of symmetry and I reflect it. So I go 1 dot away on the other side. Okay, and let's do one more point just for the heck of it. Okay, what's another easy number? I think I can't use -1 because that's where the axis of symmetry is. So let's just do plain old 1. Okay, so let's plug in 1 and see what happens. Okay, so 1 plus, so -2 times 1 plus 1 squared plus 5. Order of operations, I'm going to start inside, so that comes at 2. 2 squared is 4, so -2 times 4 plus 5. Well, that gives me -8 plus 5 is equal to -3. So I get the point 1, -3. So let's go ahead and plot 1, -3. Okay, 1, -3, right here. And again, I'm reflecting it across my axis of symmetry. Okay, notice it's 1, 2 spaces away from the blue, so I'm going to go 1, 2 spaces on this side. Okay, I now have enough, I can actually see my parabola. Okay, so all you do next is connect the dots. And there is our parabola. Okay, so your turn. Find the vertex in the axis of symmetry and graph. Okay, so go ahead and start with G. I'm going to put a graph in here, and then I'll graph it while we're trying these. Okay, make him just a little smaller. All right, so if I start with G, I want to know the vertex. Okay, so my vertex, HK, remember, opposite of what you see, and then just plain old 1. So the axis of symmetry is just x equals 2. Okay, so let's go ahead and plot both of those. Okay, so 2, 1, right here. And I'm going to dot the axis of symmetry in. Okay, the other thing we got to do is find a couple points. So I'm going to plug in 0. Okay, so if I plug in 0, I get -3 times -2 squared. Okay, -2 squared gives me a +4 times -3. So -12 plus 1 is a -11. Okay, so I get the point 0, -11. Well, 0, -11 is about right here. Okay, notice I'm 1, 2 spots away, so I'm going to go 1, 2 spots away on the other side. Okay, now you just pick whatever other number you want. I like +1 because he's in between what I've already done. Okay, so -3, 1 minus 2 is -1. And -1 squared is a +1. -3 times 1 is a -3, plus 1 is a -2. So I get the point 1, -2. Okay, so if I plot him, 1, -2 is right here. Notice I'm 1 space away, so I'm going to go 1 space away again. And finally connect my dots. Okay, does this match what the graph tells us? Well, let's check it out. Okay, A is negative. Does my parabola open upside down? Absolutely. Okay, I have a 3, so it's pretty skinny. And my vertex is in the right spot. So that is what you would want to do. Okay, go ahead and try letter B. All right, so letter B, same thing. You gotta tell me the vertex. So HK, so I'm the opposite. Okay, so let's go ahead and plot -1, -4. Okay, I need to know my axis of symmetry. Well, that's just x equals h, so that's -1. This is a Vux line, so I'm going to go ahead and dot him in. Okay, now let's plug and chug. Okay, I'm going to use the point 0 because I like using 0. So if I plug in 0, 0 plus 1 is 1. 1 squared is 1. 1 minus 4 is -3. So the point 0, -3. Okay, I'm 1 space away from my axis of symmetry, so I go 1 space away on the other side. Okay, let's pick a different number. I can't use -1 because that's my axis of symmetry, so let's use the point +1. So 1 plus 1 is 2. 2 squared is 4. 4 minus 4 is 0. So I also get the point 1, 0. Okay, notice this time I'm 2 away, so I'm going to go 2 away on the other side. Finally, connect the dots. Okay, again, I'm just going to check real quick. A is positive. Okay, my parabola opens up, so I'm okay. And that's how we do those. All right, the last thing we look at here is a word problem. Deshaun and Chris are playing soccer. Chris takes a shot on the goal. Deshaun is 3 feet in front of the goal and can reach the top of the 8-foot goal while standing directly beneath it. Can he block the shot from his current position without moving or jumping? Okay, so notice the soccer ball makes a parabola. We don't know exactly what it's going to look like. So, first thing we need to do is estimate some points. Okay, so I already went ahead and did this. I labeled a few points. Okay, the vertex is right here, and I'm estimating that to be the point 16, 11. Okay, we were told that Deshaun, or this guy, is 3 feet in front of the goal, so 25 minus 3 gives me a 22. And I know the goal is 8 feet high, so he can reach that. So I know he's at the point 22, 8. Okay, but I don't know if he's on the parabola or not. Another point I estimated was just right here at the starting point, okay, 2, 1.2. So the first thing we need to do is write this into vertex form and then use this other point to just figure out what A is. Okay, so vertex form, remember, y equals A, that's x minus h squared plus k. Well, here's h and here's k. So y equals, I don't know A yet, so x minus 16 plus 11. Okay, so to figure out what A is, I'm taking this point and plugging in for x and for y. So 1.2 equals A, x was 2, so 2 minus 16 squared plus 11. So 1.2 is equal to A times negative 14 squared plus 11. 1.2 equals A times 196 plus 11. Okay, how would I solve for A? Well, I'm going to subtract 11 on both sides. So 1.2 minus 11 is equal to negative 9.8 equals 196 times A. Divide by 196. A equals negative 0.05. Okay, so my equation is y equals negative 0.5, if I can write that correctly, 0.05 times x, I think it was 16, yep, minus 16 plus 11. Okay, so now we got to figure out if Deshaun can block the ball. Okay, so Deshaun is 22 feet, okay, away. So if I plug in 22 for x, I can figure out what height my ball is going to be at. Okay, if the ball is over 8 feet, Deshaun is not going to block it. If the ball is under 8 feet, Deshaun can block it. Okay, so let's plug in 16 and see what happens. So y equals negative 0.05 times 22. And let's see what height we get. 22 minus 16 is 6. Okay. Negative 0.05, 6 squared is 36. So negative 0.05 times 36 is negative 1.8. Add 11. We get a height of a 9.2. So that means when the ball gets to 22 feet, it's going to be at 9.2 feet high. Deshaun will not be able to block that because he can only reach 8 feet. Okay, so Deshaun cannot block the ball. Okay, so again, here we are playing again. We have the function. Okay, if he does not block the goal, or does not block the shot, will it be a goal? Well, let's figure it out. I've got this equation. The goal is at 25 feet. This is my x. Let's put 25 in for x and see if it is less than 8 feet tall. Okay, remember this was 8. Okay, so if I'm under 8 feet, it's going to be a goal. So let's find out. So f of 25 is equal to negative 0.05 times 25 minus 16, quantity squared plus 11. Okay, so negative 0.05 25 minus 16 is 9. Okay, order of operations, we do our exponents next. 9 squared is 81. Okay, multiply. Negative 0.05 times 81 is negative 4.05 plus 11 gives me a total height of 6.95. Okay, because 6.95 is lower than the 8 feet height, this will be a goal. Okay, 6.95 feet would be right about here. Okay, so the ball's going to hit right here, and Chris makes the goal. Okay, so that's vertex form. Okay, it's very useful. Biggest things to know is HK is your vertex. So homework tonight, you're on page 327. You're going to do problems 10, 12, 13, 27, 29 through 35I. I hope you guys have a great day.